Okay, so here we are, quiz number 6, problem number 1. And they're saying find the amount that results from the given investment. $100 invested at 3% quarterly for 3.5 years. So the compounding is quarterly. That means N equals 4 compoundings per year. So it's so we use the formula A equals P, 1 plus R over N to the NT. So 100 is invested, that's the principal, and the rate is 3%, over N is 4 compoundings a year, quarterly, and the T is 3.5 years, 3.5, put that in right there. Hit the buttons on your calculator, and you'll get $111.03. Okay, number 2 here. They say find the effective rate. So whenever we do effective rate, step 1, we put in $1, I should say, put in P equals $1 for T equals 1 year. Step 2, take the answer, subtract original $1 and change to percent. So there's the 2 steps we do whenever they say find effective rate. So let's do step number 1. The formula for compounded quarterly is P 1 plus R over N to the NT. So we put in P is $1. The rate is 6 1/4. That's 6.25%. So that's 0.0625 over N. N is quarterly, so that's 4 compoundings per year. The time, you put in 1 year. $1. P is $1 for T is 1 year. Hit the buttons in your calculator, and you'll get that. So then step 2, we have to subtract the original dollar. So get rid of that 1 and then change this, so 0.06398. Change this now to a percentage, move it twice to the right, becomes 6.398%. So that's the effective rate. That's the real effect of 6.25 if you compound quarterly. That ends up being a little better than 6.25. Okay, so here's number 3. We're compounding annually. So the formula is A is P 1 plus R over N to the NT. And we want to triple our investment. That means the A is 3P, 3 times the principal original investment. The rate is what we're looking for. N, what's N? Annually means once a year, so N is just 1 time a year. And then T is 11 years. N is 1 there. Okay, so there's our little equation. Now, how do we solve it? For the first step, we just divide by P on both sides, and that's gone. So we get 3 equals 1 plus, now R over 1, that's just R. And 1 times 11 is just 11. So we get to there. So now we're trying to solve for R. That's what they asked us for, is what rate. So now how do we do that? Well, remember what we learned. When you want to get rid of a number in power, when you want to get rid of a number in power, what do? You do 1 over the number, 1 over the number to the power on both sides. So I'm going to do that. I'm going to go, I don't need that. I'm going to go 1 over 11 on this side and 1 over that side. These cancel, so you get 3 to the 1 over 11 is 1 plus r. That gets rid of that 11 power. And then you can finish up by subtracting 1 from both sides. These cancel, so we get 3 to the 1 over 11 minus 1 equals r. So now hit the buttons on your calculator, and you'll get that. Move it 2 places, 10.50%. Okay, so here's number 4. Population of a colony of mosquitoes obeys the law of uninhibited growth. What does that mean? How do living things grow? PERT. We always use PERT because that's continuous growth. So it's the same formula we use for money growing continually, but it's for living things, which always grow continuously and not in jumps. Okay, there's 1,000 mosquitoes initially and 1,600 after 1 day. So let's stop right there. Let me go to a fresh screen. So this is number 4. 1,000 initially and 1,600 after 1 day. 1,600 after 1 day. Okay, so how we do these? First, find e to the r. That's the first phase. First thing you got to use. So we're going to use PERT, and we're going to put in that initial information. 1,000 initially. That's the P. It's like principal investment, but it's an original number of mosquitoes. E to the r. Then it's after 1 day. So when t is 1, the amount becomes 1,600. Now, what are we going to do with that? You want e to the r. I want this. So how do I get that? Divide by 1,000. Boom, this comes out 1.6 is e to the r. So now we got e to the r. Now you come up here in the second part, you finish the problem. Now we're still using PERT. We still know that the original amount of mosquitoes was 1,000, so that's still the principal, that's the P. The e to the r, now I know is 1.6, and the t is still there. So now I use that formula to answer whatever question they ask me in the end. What are they asking for? What is the size of the colony after 4 days? So after 4 days, that's kind of like after 4 days. That would mean put the 4 in for t right there. Hit the buttons on your calculator. You get 6,554. A lot of mosquitoes after 4 days. So that's the first question. Now the second question, they say, how long until 80,000 mosquitoes? So 80,000 mosquitoes. Now you're going to use the same formula, this formula. Again, going to answer all of our questions with this thing. Right? And they say, how long till 80,000 mosquitoes? So they want the amount over here to be 80,000. And so I need to solve that for time. How am I going to solve for time there? Let me go to a fresh screen. So A is 1,000. What was it? 1.6 to the T. So they want me to find T. How do I find T? Well, when you want to find a letter in power, now that's different than a number, right? Back over here earlier, we wanted to get rid of a number in power, so we 1 over number, 1 over number. But here I want to find letter in power, ln both sides. ln both sides is how we do it. So, oh, well, you know, that's actually second. I should say, first get the base alone. Second, ln both sides. So the base is that 1,000 right there. I got to get rid of that 1,000 because the base is the 1.6. The base is the thing that has something on him. It's got the T on it. So the A was 80,000, wasn't it? So let me go back and put that 80,000 in over here. So this is 80,000. So the first step then is to get rid of that 1,000. Boom. And so we get 80 equals 1.6 to the T. So that's step one. So we got the base alone. Doesn't have any number in front of it. It's just the base. Now step two, you put ln on this side and ln on that side. ln on both sides. Like that. That's step two. And then what does that allow you to do? That letter drops down to the front. So it becomes T. ln 1.6 is ln 80. And once that T is down on the ground like that, you can easily solve for it. Just divide by ln of 1.6. And boom, T equals 9.3 on your calculator. Okay, question number 5. It says the half-life of carbon-14 is 5,600 years. So, number 5, half-life 5,600 years. Piece of charcoal made from wood, 71%. When did the tree die? If 71% remains, when did the tree die? 71% remains when the tree die. Okay, so on half-life problems, give you a special rule over here. For half-life, in fact, I'll just write it over here. For half-life, got a shortcut here. It's A equals, you don't have to do the whole PERT thing. The shortcut is you can put the 0.5, that's the half, T over the half-life. Like that. It'll always work. You can just do it like that. Oh, I forgot the P. It should actually be P right there too. So, so there we go. So we'll just use that. So here we go. The half-life is 5,600 years. So, so this will be P 0.5 to the T over 5,600. And they're saying 71% remains. That means the amount left is 0.71% of the original, of the P. Right? P is the original. Right? Like with money, P is always the principal investment, the first amount put in. So if I said my bank account is 71% of my money remains. I took a big loss on the stock market and 71% of it remains. Then it's 71%, 0.71 times the original principal. 71% of, right? It's 71% of P, of the original principal. 0.71 times P. So that's what you put in for A. That's what they mean by that. Okay, now we can divide by the P. Just drop off the P on both of those. So we get 0.70. Oops, getting a little scribbly there. Get 0.71 is 0.5 to the T over 5,600. Now I want to solve for T. What did we learn right back here? When you want to find the letter in power, first get the base alone and then ln both sides. So the base is already alone. I'm going to ln both sides, and that whole thing will drop down. Let me bring it over here. So this will be ln 0.71 is T over 5,600 ln 0.5. See how that whole t thing just dropped down when you ln both sides. Now we're trying to solve for t, so we should divide off the ln 0.5 on both sides, and we get t over 5,600 is ln 0.71 over ln 0.5. Last step to get t alone is to multiply both sides by 5,600. Cancels, so t will equal ln 0.71 over ln 0.5 times 5,600. And if you hit the buttons on your calculator, you'll get the answer 2767. That's how many years old the tree would be if it's got 71% of its original carbon-14 remaining. It's 2767 years old. That's how long ago the tree died. Okay, and then number 6 here, we've got reacting with water in an acidic solution at a particular temperature. Compound A decomposes into compounds B and C according to the law of uninhibited decay. That means PERT. So they're saying we're going to use PERT. And it's saying an initial amount, 0.4 m, whatever m is, of compound A decomposes to 0.37 in 30 minutes. How much of compound A will remain after 2 hours? Okay. So let's write those facts down. Initial amount, 0.4 m, so number 6. So the initial amount is 0.4 and 0.40, and then it goes down to 0.37 in 30 minutes. So 0.40, initial 0.40 down to 0.37 in 30 minutes. I have that right? Down to 0.37 in 30 minutes. So let's just stop right there. So we're able now to do phase 1. Phase 1 is all about finding the e to the r, remember. So we're going to use PERT. The initial amount is 0.40, that's the P. Right? P is the principal amount that you put in the bank at first, or the initial amount of a compound or living insects or bacteria or whatever. E to the R. Now, in 30 minutes, so when T is 30 minutes, the amount is 0.37. See that? So now, we plugged in what they said. We want to find e to the r, remember. So how do we get e to the r? First divide by the 0.40, and we get e to the r times 30. This is over here, this side will be 0.925 on your calculator. Okay, now, what am I trying to do at this point? This is where it gets tricky for people. Let me help with this. Remember what we're trying to find, e to the r, right? So in other words, I don't want to do ln. I'm not going to do ln on both sides. Why not? If I did an ln on both sides like that, then this whole thing would drop down. I don't want the r to drop down. You see how I want the r up here? I want the r to stay in power. I don't want to drop the r down. I just want to get rid of that 30. You see, I just want to get rid of that 30. If I can get rid of that 30, then I'll have e to the r. So what's going to get rid of that 30? How do you get rid of that number there? Remember what you do? You 1 over 30 power and 1 over 30 power both sides, and these cancel. And so you get e to the r is 0.925 to the 1 over 30 power. And just leave it like that. Okay, now let's bring it up here. Second, you finish the problem. So now we're going to go back to using PERT. We're still using PERT. But now we know the P, the principal amount, is still 0.40. That's the amount it started. The e to the r now, the e to the r is this whole thing, right? That's what e to the r equals. 0.925 to the 1 over 30. Get that a little better. 1 over 30. And then the t's still up there like that. And actually, the best thing to do with the t, since it's a t over 1 multiplying that fraction, just put it on the top, because it's just going to be t times 1 on the top and 1 times 30. So the t will just go to the top. So it'll just be to the t over 30 powers. Everybody see what happened there? So that e to the r is 0.925 to the 1 over 30. So e to the r became 0.925 to the 1 over 30, and then the t just went to the top. Okay, so this is our formula. This is our golden ticket, so to speak, that will answer every question from this point forward. Okay, so what do they want from us? They want to know, after 2 hours, how much remains. So 2 hours, so t equals 2 hours. That means just plug in 2. 2. So I just put the 2 right in there in the t spot. And hit the buttons on your calculator. And you should get 0.29. That's how much remains. That's that question. Now the next question is, they say there will be 0.10 left in how many minutes? So 0.10 left. Oh, wait a minute. I made a mistake on that last problem, didn't I? 2 hours. My formula had been in minutes up to then. So 2 hours equals 120 minutes, doesn't it? 2 times, times 60. It's 120. So really, I made a mistake here. This should have been 120 minutes, 120 over 30. And then you'd get the answer, 0.29. Now for the second part, it says, when's it going to be 0.10? It's basically what they're saying. How many minutes till it's 0.10? So now they're saying take the same formula, keep using, and now you want the amount to be 0.10. And the rest of the formula is the same. 0.40, 0.925 to the t over 30. So let's go to a fresh screen and solve that. So we have 0.10 is 0.40, 0.925 to the t over 30. So you see what's happening there? They asked me, it'll be 0.10 remaining in how many minutes? So I put in the amount to be 0.10. So the amount over here is 0.10. Now I'm going to solve for t. So how do I solve that for t? First divide off the 0.40. Boom, on both sides. And this will become 0.25. Like that. And now I want to solve for t. So what are you going to do to get that t down? ln. So now I am going to ln because I do want that whole t to drop down to the front because I'm trying to solve for it. So that'll become t over 30 times, whoop, I forgot the ln there. T over 30 in the front of the ln 0.925. The other side's ln 0.25, okay? So now just solve for t. So divide by the ln ln.925, ln 0.925, like that. So then we get t over 30 is ln 0.25 over ln 0.925. Last step to get t alone, multiply both sides by 30, and it cancels. So here it is. If you can read, that's a 30. I just get kind of scribbly there. So hit the buttons on your calculator. 533.5. 533.5 minutes until 533.5 minutes until it's reached that level. So there's our answer.